is like this, and you're the only one that.
All right, guys. Here we go. Start with our notes right now. Here we go. What you may or may not know, because you haven't spent a whole lot of time with trigonometry, is that just like there are different units that we can measure length with, so we could use inches, feet, meters, lots of ways to measure length, there are multiple ways to measure angles. Up until this point of your life, every angle you've dealt with has been measured in degrees, right? There's 360 degrees in a revolution, and that's how you've measured your angles. You had 60-degree angles. You've had 45-degree angles. Well, we are at the transition point. We are entering big people math, and in big people math, like pre-calculus and beyond, pre-calculus is kind of on the edge. We use both. But once you leave this class, you'll only use radians. All your angles will be measured in radians. So we need to figure out what would radians even mean, and how do we change degrees into radians and radians into degrees. So that's our first task today. So let me get notes to my notes. And let's get started.
Cooking with Tyler Johnson.
Cooking with Derek, you say, who's cooking with Derek? Come on, guys. I only know my first two. Where's she at, bro? She's chefing it up.
You been in there?
What? She a sous chef or some shit? Fried rice, cookie, lasagna, mac and cheese. You be grilling this shit too? Grilling with.
All right. Here is the key relationship. Back in math class.
What's up?
Back to my friends.
It's the seating, bro. You know what?
But here we go. Pi radians is 180 degrees. So that is your fundamental relationship. A radian, and I am not going to ask you for this definition, but just because you're probably wondering, well, what in the heck is a radian? What are you talking about? If we took a circle, and let's say the radius of the circle was 5, and then we took a piece of string, 5 units long, and wrapped it around the circle so that the arc here was the same as the radius. So if the radius was 6, that would be 6. That angle formed is 1 radian. A radian is the angle that's formed when you wrap a radius around the circle. And there are 2 pi radians in a revolution, because 1 pi is 180, so 2 pi's would be 360. So when you go out in the icy parking lot and you do 360s, now you can go out and do 2 pi's, right? Because that's a revolution. All right? Now, how do we change, using that fact, 2 pi's, how do we change 100 degrees into radians?
You supposed to come to the
You're all going to do a better job of getting here on time.
Yes, ma'am.
Correct.
For my sister, that's it.
Correct.
You coming to the next one now?
All right. There, as always, there's lots of ways to do this, you guys. We are going to do it. I'm going to show you how to do it one way. It's how I'm always going to do it. If you choose to do it a different way, figure it out. Maybe you Googled or have a tutor or something, that's okay. But every time I change degrees into radians, radians into degrees, I'm going to set up a proportion. I know that pi radians is 180 degrees. So I'm going to set up the fraction pi over 180. So this is pi radians, 180 degrees. And then I'm going to set that equal to how many radians over 100 degrees? That's the question. I'm doing problem A. Does that make sense to you? So pi over 180 equals something over 100. Now, does everybody understand why the 100 is in the denominator? Can you explain to me? Why is the 100 in the denominator? Because it's a degree just like the 180. So if you're going to put pi over 180, that's radian over degree, it's going to be radian over degree. Okay, then I'm going to cross multiply. So 100 pi equals 180x. And then, you need 4 of them, and then if I am solving for x, what am I going to do? Divide, absolutely. And usually, when you do this, you guys, usually there is quite a bit of simplifying that you can do. So I have a 0, 0, I can cancel those out, that's like 10s, get rid of those 10s. Then I have 10 over 18, which is 5 over 9. So don't forget the pi is there, and your answer is 5 pi over 9. How many radians is 100 degrees? 5 pi over 9. It has to be on the 5. Yeah. Okay. Negative 60 pi over 180 equals what? I'm changing negative 60 degrees into radians. So what's going to be this fraction? X over negative 60. The negative doesn't change a thing. I mean, obviously my answer is going to end up being negative, but it isn't going to change a thing. So negative 60 pi equals 180x. Now what? I cross multiply. Now what? Divide by 180. So what does x end up equaling? Be careful. Negative pi over 3.
Stop the trolling.
All right. Now, while I'm changing my attendance for the 12th time, would you do that last one? Would you do 210 degrees?
Don't know.
Where did Daniel go?
That's what I mean. You always
All right, what'd you come up with? Beautiful, that's exactly right. Hopefully everybody got 7 pi over 6.
Yep.
Because when you reduced 210 over 180, 3 goes into that 7 pi over 6. Does anybody have a question about that?
Wouldn't it always just be like 180 divided by 100?
Yeah. Yeah. Because you're always gonna have 180x over here, so you're gonna be dividing. All right, everybody okay with that? All right, now we're going to go, or now we're going to get our, or now we're gonna go the other way. We're gonna change from radians into degrees. Now this can be a little easier because we know that pi is 180 degrees, pi radians. So we are wondering about pi over 4. Well, isn't pi 180? So aren't we just doing 180 divided by 4? Since we know pi is 180 degrees, we want a fourth of that? So what's 180 divided by 4? 45. So the answer is 45 degrees. Two pi over 3. Same thing. We know that right there. Forget the 2 and the 3 for a second. We know pi is 180. So we have 2 180s divided by 3. So you can either do 2 times 180 divided by 3, or I like to do 180 divided by 3 times 2. It doesn't matter. Either way, your answer is going to be 120 degrees. And you will always either have your own calculator or a baby calculator to help you with this arithmetic. Okay? All right, you do negative pi over 6. What's negative pi over 6? How many degrees is negative pi over 6? I heard a negative 30 from somebody. We have agreement with that? Negative 30?
Yep.
All right, 7 pi over 6. Go ahead, you guys can do this. $210. Hey, I want you to look up at the problem we just did. Didn't we have to change 210 into radians? And what did it change into? Look at problem 1C. 7 pi over 6. So now we're just going backwards. We're changing 7 pi over 6, and we got 210. So one more time, in case somebody missed it. How did we get 210? We let this right here be 180, because that's what it is. So we took 7 times 180 and divided by 6. I like to do 180 divided by 6, which is 30, times 7 is 210. Doesn't matter how you calculate it. Now, E is different. What is different about E? There's no pi. So we're not going to be able to shortcut. We're going to have to go back to our proportion. Pi over 180 equals what? Now be careful. It's either going to be x over 2 or 2 over x. Which is it going to be? 2 over x. Why do you think it's 2 over x? Because what is the unit on that 2? That is a radian. Look, change the following radians. So that's 2 radians. When I put pi over 180, isn't this radians and this degrees? And when you set that fraction up, if you have radians over degrees, then you gotta have radians over degrees. So then we'll cross multiply. you're solving for x, so you're gonna divide by pi, and there is the answer to the question. I know that is a weird looking number, but, I mean, we just have to get used to that. And then F is crazy easy. Pi radians is how many degrees? 180. 180, exactly. Pi radians is 180 degrees. All right. We're gonna need our calculators here, our big calculators, so go ahead and get that out. If you forgot yours, please remember it from now on and make sure it's charged. So charge it at home or bring it in early in the morning or after school or something. All right, now here we go. Little background information. You know how, well, that's not really a real clock, but you know how a clock, an hour is once around? And that hour can be split up into 60 pieces called minutes. And then each minute can be split up into 60 pieces called seconds. Well, angle degrees work the same way. So 1 degree is 60 minutes, and 1 minute is 60 seconds. So angles in degrees work just like hours on the clock. When we write an angle with degrees, minutes, and seconds, an example would be 32 degrees, 18 minutes, 12 seconds. That's the notation that we use. So this obviously is degrees, so that's 32 whole degrees, 18 minutes, so 18 sixtieths, and then 12 seconds. Okay? Your calculator, we used to have to do this by hand. Your calculator will change angles into degrees, minutes, and seconds. So here's what I want you to do. We're ready for 3A. First thing I want you to do is go to mode, top row, and make sure that, for me it's the 3rd row down, I'm not sure what it is for you, but you have a radian and a degree line. Make sure degrees is highlighted because we are working with degrees now. Okay? There will be times when we'll want to highlight radians, but right now we're in degrees. So go to mode, click over to degree, and press enter. Okay? Now, I want you to type 100.4. Just type the number in, 100.4. And then I want you to go to second angle. And the angle button, it's a little blue, it says angle, and it's above the apps. It's right next to the math button. You see where I'm pointing? Everybody find it?
Yep.
So second angle. And if you look, there's a whole bunch of stuff there. I want you to click down to DMS. Any guess what DMS stands for? Degrees, minutes, seconds. So click down to DMS, press enter. And it says 100.4 is what we typed in, and that's 100 degrees, 24 minutes, and 0 seconds. Everybody get that?
What is the 1 and 11?
What is what?
The 1 and 11, like above the
No,
24.
that's the minute mark,
Oh.
and that's the second mark. It's like feet and inches, but it's minutes, seconds. All right, did everybody get it? All right, so how do we get degrees, minutes, seconds? We press DMS.
We're gonna have to be switching back to radio.
No, not for a while. All right, let's do the next one. 18 .375. Second angle DMS.
18.
Did you get 18, 22, 30?
Yes.
And that's the way you write your answer, 18 degrees, 22 minutes, 30 seconds. All right, you do the last one. Don't, just type the negative in, don't worry. That doesn't change anything.
Is it okay if I comments in between the numbers?
Your answer should be written exactly like this. There should be any other marks. Negative 20 degrees, 25 minutes, 12 seconds. All right, we ready? Now we're gonna go the other way. This is called, when we had the 100.4, that's called a decimal degree. It was a degree measure written as a decimal. This is degrees, minutes, seconds. Now we're going to go backwards. We're gonna start with degrees, minutes, seconds, and go back to decimal degree. So we have 132.11. So 132 degrees, 11 minutes, and we want to change that into a decimal degree. Okay, step one, type 132. Just 132. Go into second angle, and you see what the very first option is? It is the degree mark, press it. So now you should see on your calculator 132 degrees. Okay, so now we're gonna type 11. And then back into second angle. And what's right under the degree mark? The minute mark. So click down and press that. And then press enter. And you should have gotten 132.183 degrees. All right, so here we go, 18, 12, 13. Start by pressing 18. Second angle, degrees. And then 12, second angle. Now before you do anything, I want you to look at that list. Our minute mark is there, right? So we're gonna press minutes. But you see a second mark there? No, that's hidden somewhere else. But let's go ahead, get your minute. So you have 18 degrees, 12 minutes. Everybody caught up?
Mm-hmm.
Okay, now we're gonna press 13. And here comes the super secret.
Nope.
Look above your plus sign in green.
Ooh, I see.
Above the plus sign in green. So we press alpha plus, and that puts in your
18.
minute or second mark, and that's 18.204 degrees. So where is the second mark for some unknown reason?
Alpha.
It's
Well,
alpha plus, right, it's above the plus sign in green. Green means you use the alpha button. There we go. All right, you do the last one. Negative 152, 18, 39. See if you can remember.
Oh, I just.
Good boy.
52.3108.
Mm-hmm.
Where's your calculator?
All right, we need to make sure we practice with our calculator enough to get that figured out. All right, part 5. We need to write a little formula down for part 5. So over here on the side, there's something very simple, little formula. Arc length equals radius times radians. Arc length equals radius times radians. So here is the situation for problem A. The radius is 10. The central angle, this guy right here, that is called a theta, and it is simply a variable, a Greek letter, a variable, that stands for that central angle, the angle right here in the center. Trigonometry was studied, developed by the Greeks, so we use the Greek alphabet a lot for our variables, alpha, beta, gamma, theta. This happens to be a theta. It's like an X. All right, and our job is to find the arc length. That's our job. This right here. Yes, if you were listening earlier, some of you already know what the answer is. But the answer can always be found with your formula. The arc length, I don't know what that is. The radius is 10, and the radian measure of the angle is 2. So what's the answer to the question? 20. Arc length is 20. Now you might be thinking, oh, Mrs. Ford, wait a minute. How do I know that's 2 radians? Could that be 2 degrees there in the middle? And the answer is, if it's a degree measure, it needs to have a little degree mark on it. So since there's no mark on that 2, it's understood to be a radian. If you are ever unsure, because sometimes I'll write, sine 30, and I forget to put the degree mark. So if you think it should be a degree, ask me, because sometimes I leave it off accidentally, but not this time. That's 2 radians. All right, let's try B. Same picture. This time, we know the angle is 1.5 radians. We know the arc length is 6, and we're finding the radius. What does our formula say? Our formula says arc length, I'll write it out again. Yep. So arc length equals the radius, I don't know what the radius is, times the radians. How do I solve that? Divide by 1.5. So what's my radius? My radius is 4. 6 divided by 1.5. This little formula is so easy to use. And if you just plug stuff into it, you'll have your answer without any difficulty. All right, let's look at C. Arc length is 10, radius is 4, theta is unknown. So what does my formula say? Arc length equals radius times radians. So it looks like my radians are 2.5 or 5/2. Incredibly easy. Arc length equals radius times radians. Plug in what you know. Now, D, just when we thought we had everything under control, D is going to throw a snag at us. D says my central angle is 30 degrees. My radius is 10, and I want my arc length. What is the snag here? The angle's in degrees. And in order to use the formula, the angle must be in radians. Remember the very first thing we did today?
Yeah.
We changed degrees into radians. So step one, this is gonna be a two-step problem. Step one, we gotta change 30 into radians. Pi over 180 equals x over 30. That's step one. So I'll cross multiply.
35.
And when I reduce, it looks like I get
1/6.
pi over 6, 1 pi over 6. Now, you don't stop there, guys. That isn't the answer to the question. What is that? That is this angle right here.
Mm.
Only now it's in the right unit.
Yep.
It's in radians. So now I can find my arc length. My arc length equals my radius times my radians. I'm not going to freak out with the arithmetic. How do I multiply fractions? This is 10 over 1 times pi over 6. How do I multiply fractions? 10 pi over 6. And then reduce it to 5 pi over 3. And that is your final answer. Man, it feels good to be back in school, doesn't it?
Mm.
All right, now, with your partner, I want you to do the last problem. So, think about what we just did with this one we just finished. With your partner, see how far you can get with that. I'm gonna put a sweater on. Yeah. My screen's a wrinkled mess, though.
Like this one. Just the R's. So it's 10 over 9.
What you talking about, Lucia?
This the Hey, guy, you can do it. I'm sorry.
Do it again. Do it again, Will. Do it again.
Wait, you divide?
Pressing right now.
Okay.
What are you doing first? What is your first dilemma?
Change 90.
You gotta change 90 degrees
To a radian.
into
A radian.
radians.
Radian
because I need radians in my formula. I know my arc length is 10 pi, R is what I'm looking for, but I need this. So pi over 180 equals something over 90. So 90 pi equals 180x. Did you come up with pi over 2?
Yeah.
Now, next time, maybe you won't need to go through all those steps, because I want you to think about this for a second. If 180 is a whole pi, then doesn't it make sense that 90 would be half a pi? So if you can logic that out, it's perfectly okay. 180 is a whole pi. 90 is half of that. So obviously it's pi over 2. So we put pi over 2 right here. All right, everybody good to this point? Now you have arithmetic. Don't let the arithmetic bother you. What do you want to do? Don't you want to divide by pi over 2? I mean, is that what you would want to do maybe? But when you divide by a fraction, what does that mean? Keep, change, flip. So this is going to be 10 pi divided by pi over 2. So 10 pi times 2 over pi. And now we multiply across, so did you get 20 pi over 1 pi? So what's the answer to the question? 20.
I just got 20.
That's what
You just got,
Because, well, when I divided, like, changed the 90 degrees, I got 0.5.
no. You saw it pi, it's pi over 2. It's pi over 2, yeah. Yeah, so the answer is just 20. Answer is 20. This pi is still there, that's pi over 2. Okay, all right. Now, I'm not gonna have you pull your books up, but now we're going to talk about one of the big uses of trigonometry is in navigation. Planes flying, ships sailing, and so there's some basics of the compass we're gonna talk about. So when I say compass, do you know what I'm talking about? What am I talking about? A little thing that tells you north, south, east, west, right? So, the basics of the compass. Here it is. Where's north?
Up top. Oh,
And then this is south, and this is east, and this is west. Right? Now, if I draw this perfect diagonal line right there, right in the middle of north and east, that is called northeast. And if I draw this one in, that is called southeast. And this one is southwest. And this is northwest. Does that make sense to everybody? You're comfortable with that? Okay. Now, this may be something you're not so familiar with. If I draw this in, right in the middle of north and northeast, this one is called northeast. Because that red line is on the north side of the northeast. This one would be east, southeast. This one, what would this one be? West, northwest. You guys are amazing. Okay. And we can do the same thing. Now we're going to put angle measurements to these. Okay? So, on the compass, due north is 0. Due south is 180. Due east is 90, and west is 270. Okay? Now, remember our northeast line split this right here. So what's the measure for northeast? 45. This red line split that, so 22 and a half. Beautiful. All right, let's come down here and do a couple of these. We're not going to do all of them, but we'll do a couple of them. Let's do southeast. Now remember, southeast split this quadrant. So this was 90, and then another 45. So 135 here. What about east southeast? It was 90, and then how much more? 22 and a half. So this one would be, what is that? 112.5. And so we can give every direction an angle measure. So that's what we're doing for problem A. 6A. East, southeast, I already did. East, southeast is 112.5. This is 6A. Now I'm on 6B. What about southwest? Now use your head here, think about this. Southwest is 180 and 45 more? 225? West, northwest, right here? All right, so I gotta go all the way around to here, that's 270. And then another 22 and a half?
Yep.
So 292.5, did I do that math right? And then finally, northwest. I don't have that one drawn up here. So northwest would be this. Now I want everybody to understand that's where northwest is. It's in the northwest quadrant on the north side.
Yep.
Here's the northwest line, I'm on the north side of it. So let's see.
337.5.
Let's see, what is that gonna be? 337.5. How did we figure that out? A couple different ways you could do it. First of all, isn't it all the way around except for this little bit right here? So could I take 360 minus 22 and a half?
Yep.
That would work. I could also just start adding up the increments. You know, 270 and another 45 and another 22.5
Yep.
to get my measurement.
Are we gonna have to like use that angle? Like each degree on?
Because you're gonna get problems.
Don't talk to me like that. Like, yeah, you know how we do.
Flying on everybody. All right, folks, listen. We have one more problem to do.